Okay, for second example, so what are we supposed to do is we're going to sketch this. So we're going to start with a very simple function, and we're going to do the transformation and use that to sketch a complicated function that looks somewhat like this. For the first one, I'm going to sketch f of x equal x minus 2 plus 4. So as I mentioned to you just now, so we're going to start with a very simple function. So how do you identify what kind of simple function it could be? For example, you could either start with f of x equal x, or it could be something f of x equal x squared, or f of x equal x cubed, and so on. So that is going to depend on the function given. And here I know that if I were to expand this, I will end up with x to the power of 2. So that is why I'm going to start my calculation with f of x equal x squared. So instead of f of x, let's suppose that it's going to be a function g of x. So g of x is going to equal a graph of x squared. So if I were to sketch this, so it's going to be just a very simple function. So we know that for the case of x squared, so my minimum point is going to be at 0, 0. So if I were to sketch it, somehow it's going to look like this. Okay, so that is going to be my graph gx equal x squared. Okay, so now the next step, what I'm going to do is I'm going to start making the function more and more towards what we wanted gradually. So now what I'm going to do next is I'm going to add this bracket right here. So I'm going to make it now into a function of x minus 2 to the power of 2. So what differs over here is that when I go from this function to this function, so I change the x. So that is why. So what happened here is that my function is transformed to g of x minus 2 without the square. Okay, so whenever I come across x, I change that to x minus 2. So that is why x over here become x minus 2 square. And according to the transformation that we have seen before, so when you change from gx to gx minus 2, so what happened here is that, so your graph is shifted. So is it supposed to be left or right for this case? So it is minus right here, and the minus is giving us a hint that is going to be shifted to the right hand side. So graph shifted, so that's not my pen, graph shifted to the right. So how many units? So that is going to be 2 units. So graph shifted to the right 2 units. Okay, so let's sketch my graph now. So I'm going to shift it to the right 2 units. What happened is that let's start with the minimum point right here. So previously it's 0. So now the new minimum point is going to be shifted this way. So it's going to be at coordinate 2 and 0. Okay, and I know that if I were to expand this function, I will end up with a function of x squared minus 4x plus 4. So here what happened is that the intercept will be at a value of 4. So somewhere over here, so this is going to be a value of 4, and there goes my minimum point. So the graph is going to look like this. So let's say 4 somewhere over here. So that is my 4. Okay, because I don't want to sketch another curve. Okay, so that is how the graph looks like when it's shifted 2 units to the right. So this is going to be our new minimum. So it's going to be at 2, 0. Okay, then I'm going to change the function again, because here I'm still missing the plus 4 at the back. I'm still missing this part, and now I'm going to create that. So I'm going to change my function again, and from here, so I'm going to make it into x minus 2 square and plus or 4. And I know that, so going from this function to this function, so what happened is that, how does my function change? So it's going to be g of x minus 2, and I'm going to have a plus 4 at the back. And I know that when my function has plus 4 at the back, so what happened? So what happened is that the graph is going to be shifted upwards because it's a plus for how many units? So that is going to be 4 units. Okay, and so therefore what happened is that so this is going to be my graph. So now this is going to be shifted up 4 units. So what is going to be my new minimum point? So it's still going to be at coordinate of 2. Okay, but instead of 2, 0, so the new point will be at 2, 4. Okay, so that is going to be my new minimum point. So let's put over here, it's going to be 2, 4. And as for the intercept as well, so instead of like intercepting at 0, so let me elongate my axis a little bit. So this is somehow going to intercept at value of 4. 4 plus 4, so which is going to be 8. So if I were to sketch, it's going to look something like this now. And what is going to be the value right here? So intercept is going to be at 8. So that's how the graph looks like. So basically what happened is that the transition, so this is my first function. I start with this one. So I start with x squared. So which shape is looks like this. And then I form the part for which I have x minus 2 squared. So that is my second function by simply shifting my graph to the right hand side 2 units. And then I add the third bit, so which is going to be the third one. So I have g of x minus 2 plus 4, which is what we wanted. So what I have to do is I have to shift my graph upwards by 4 units. So basically this is going to be how the graph x minus 2 squared plus 4 looks like. All right, that will be the idea. Okay, for second example, so it's going to be pretty much similar idea will be applied. So I have a graph of f of x equal x plus 3 minus 5. Okay, first of all, so I'm going to start here. I have x to the power of 1. So of course, my first function, I'm going to sketch gx equal x. So this is going to be the graph, and gx equal x. We know that it's going to go through the origin. Okay, so it's going to pass through the origin. So that's how the graph looks like. And then I'm going to extend the idea a little bit more. So what I'm going to do is I'm going to create the absolute function. So g of x is going to equal absolute of x. Okay, let me remind you the case about absolute. So let me scribble one here. So the thing about absolute is that, for example, if I have f of x equals square root of x, remember f of x is the same as y. So I'm going to have y equal, not square root, y equal absolute of x. So what happened is that we know when we have absolute, so this value on this side, it could either be 0 or it could also be positive values only. So that is why. So y could only be a minimum value of 0, and it could only be positive values. So that is why when we sketch for graph, and this is going to be the y-axis, so this part over here is when y is greater than or equals 0. So this part down here is when y is less than 0. So meaning that when you have absolute function, there is no way that it could be down here. So it cannot be down here, but everything is going to be on the top of this where it is 0 or a positive number. So that is why when you want to create an absolute function, so all you have to do is reflect. Okay, so what do I mean by reflect? So this is how the graph is going to look like. So whatever that goes underneath, and I'm referring to this over here, so I'm going to reflect it up and using the x-axis. So therefore when I reflect that up, so what happened is that my function is going, and this side it remains, so this side doesn't change, it's still going to be the same. But this side over here, when I reflect, I'm going to treat that this is going to be a mirror. So automatically the other side is going to look like this. So I cannot have any negative value down here. Everything should be on the top because it's an absolute function. My y value should only be 0 and positive. So this is going to be the graph of gx equal absolute of x. So reflect negative values on x-axis. Okay, so this is what I did, and now I'm going to transform that again. So this time I'm going to create the more complicated function. So I'm going to create the x plus 3. How does my function from x to become x plus 3? So something must have changed in here. Okay, so when this is x, this is x. So when I change this to g of x plus 3, so this is going to be x plus 3. And we have seen a similar example previously in A. So what happened is that my graph is shifted. Shift graph 3 units. So it's a positive. So it's going to be to the right. Sorry, positive means to the left, not to the right. So shift graph 3 units to the left. Okay. So let's capture the important points. So what are the important points on the graph here? So I think that important point is going to be here. So the fact that it goes through 0, 0. So now that we shift the graph 3 units to the left, so that turning point is no longer going to be at 0, 0, but it's going to be somewhere over here. So which is going to be -3, 0. So therefore the graph is going to look like this. And when we substitute, so this is going to be where x is equal 0. So when I substitute x equals 0 in my equation, so I will get y is going to equal 0 plus 3, which is going to equal 3. So I know that this intercept point is going to be a value of 3. So that's how it goes. Okay, and now we are closer and closer towards our final function. And from here, I'm going to change it right away into what we desired, which is going to be this graph. So I'm going to make it into x plus 3 minus 5. Is that minus 5? Yeah, it is minus 5. So this is going to be my final function. And how do I change this graph? So I just to add the plus 5 at the back. So it's basically graph of g x plus 3 plus 5. So what happens when I add plus 5 at the back right here is that, so my graph have to be shifted upwards by how many units? So that is going to be 5 units. So again, all you have to do is capture the important points, which for this case, I think it would be this turning point and also the intercept. So you just shift it upward, shift downwards 5 units. That's minus. Sorry about that. So this is downwards. Yeah, it's a minus 5. So this is minus 5. So let me highlight that again. Okay, so I'm going to be shifting things downward. So therefore my axis is going to be different somehow. Okay, let's put it like this again. So now let's capture the important points. So my turning points, when I bring this down 5 units, so it's going to be no longer at -3, 0. So it's still going to be at -3, but here, so it's going to be at -3, -5. So this is going to be my turning points. And what happened to the intercept? So for the intercept, I'm going to have 3 minus 5. So that is going to be a value of somewhere over here. So let's say it's going to be -2. So therefore, my function is going to look something like this. Okay, so that is going to be my function. Of course, my sketching over here, it doesn't really represent what should happen because the scale is not the same. Okay, but